Algebra 1 students, welcome to your 5.7b notes using Desmos Graphic Calculator to find a line of best fit. We're going to use a process today called regression. We let the machines do the work for us, but we have to know what it means and how to set it up, so we're going to talk about that. So let's start with some terminology. First, a correlation coefficient, R, is a measure of how well a data set is fit by a model. Now you can see on this chart here, we go from an R value that's close to -1 onto a close value or an R value that's close to +1. The biggest difference between -1 and +1 for R values is that one has a negative slope, that would be the negative R value, and the positive R value indicates a positive slope. And we use words like a positive correlation. In other words, as one value goes up, so does the other. Whereas in a negative correlation is one value increases, the other decreases. Okay. Now these graphs that you see of the middle of these five, especially the middle one, we can't use that data to get very accurate predictions of future results. So we don't really like R values like 0, 0.6, -0.6. Those are pretty mediocre. Now we'll talk more about R values in a minute. This little format you see down here, Y sub 1, and it's a tilde symbol that we're talking about there, mx1 plus b. That's what we can use on Desmos Online Graphing Calculator, and we'll take a look at that in a moment. So here we go. Let's jump right into the problems. We're going to use a graphing calculator to make a scatter plot for the set of data, identify the correlation, sketch a line of best fit, and find its equation. Now, you're going to have to work on two screens at once as you do this kind of thing if you're like me. So what I'm looking at here is, okay, I've got input values of minutes played. 28, 35, and 8 are the first three I see here. So what I'm going to do is go to Desmos Graphing Calculator. And you can get to Desmos Graphing Calculator. There's a link. If you're on my website, there's a link right at the top. Or you can just see the URL right here, desmos.com/calculator. That'll get you there. Now what we're going to do is go to the plus sign and enter a new item. And what we're going to enter is a table. Now it automatically puts input values of 1, 2, 3, 4, and 5. Now I need to look back because I've already forgotten the numbers. 28, 35, and 8 were the first three X values we had. 28, 35, 8. I'm going to get rid of these extra ones down here. And then our first three values for Y were 16, 13, and 2. So I'm going to type those numbers in. And as a matter of fact, I'm going to kind of cheat a little bit. I've already punched in all these numbers on a different form, and here it is. One thing you might notice is when you are on this graph, yours probably looks something like this. To start with, you're going to have to adjust that window. Now, if you have a touchscreen device like a Surface or an iPad, the adjusting of the window is actually not too complex. It's a pretty simple thing. Just use pinch and zoom. If you want to only change the vertical dimensions, pinch and zoom right on the vertical axis, the y-axis. If you just want to stretch it out horizontally, you can pinch and zoom on the x-axis. Okay, one more little piece of advice. So I've got all this data. It takes up a lot of space. That might be a little distracting to me. So what I'm going to do is actually hit plus, and I'm going to put a folder in here. And I guess I missed. Let's try again. Okay, there's the folder. And I'm just going to grab in the blank space over to the left, if you watch what I'm doing, and I pull it up, and then as soon as there's a little vertical line that shows up, I can drop it into that folder, and I can basically hide the data. That's not a necessary step, but it just helps clean things up a little bit. So right now what I'm seeing is essentially just the graph. This is what it looks like. Now, for Desmos to be able to enter a regression equation, it's really very simple. I'm just going to type this in. Y1, and it automatically knows, I mean a subscript, is approximately equal to. Now if you're using their keyboard to get that tilde symbol, you just hit ABC, and then it's this button right here. I've hit it twice, so I'm going to do it once. And then I would type M times X sub 1 plus, and then I have to go back to the keyboard, or I can just type it on my own, plus B. Okay, I get a lot of information from this. First of all, I've got a line of best fit, and that was really fast, wasn't it? Okay, so here's the line of best fit. Now, some other things to point out. Right here, this says my R value is 0.885. Okay, that's an important piece of information. I've also got the key information as far as what my slope would be. That's right here, 0.775. And the y-intercept, negative 5.8. All right, so going back to the notes, the question said to find the equation. So essentially, I can just write that information down. Sorry if I'm messing with your eyes here, but I need to be able to see all of it to be able to answer the questions. And the question says to identify the correlation. Okay, well, that is a positive correlation. It doesn't exactly say this, but I'm going to go ahead and state that the R value is about 0.885. And then it does say to write find the equation. So I'm going to do that. Y equals, and it's positive 0.775 x minus 5.8. Now this does in fact say to go ahead and sketch it. We've got the sketch right here on the graph. You can actually just get the sketch from there. I'm not going to take the time to draw that sketch by hand. All right, so there's our first one. That's a pretty straightforward situation. Let's keep going here. Let's take a look at our next problem. So in number 2, I've got a comparison of horsepower and gas mileage in certain cars. What I want to do is actually create a new graph on Desmos and then enter this new data. So you can just do X1 would be your horsepower and your output would be the mileage. Again, to enter that new data, if you're on Desmos, there we go, now I'm on Desmos, you can just simply click on these 3 bars right here and hit new blank graph. Now I've got my data entered. Pause your video and get your data entered. Okay, welcome back. I'm taking a look at some of these questions now. The first one, it says to make a scatter plot, so I can do that. We'll make a scatter plot. I've actually already got a scatter plot here, but here's the thing we have to consider. I don't see it, and the reason I don't see a scatter plot right now is because these x values go from as small as 110 to as large as 255. So I'm going to hit graph settings and change those x values. Negative 10 is probably okay, but I'm going to go like to 300. I have a similar situation on y values. They're as small as 13, but then they go all the way up as high as 35. My graph doesn't show numbers that big, so I'm going to put like, I don't know, 45 in here so I can see this. And what do you know? I have lovely data. By the way, you can also just cut and paste this data from a table, like an Excel table or something using Google Forms, and it works lovely. All right, again, let's go through the process and create that scatter plot. Y1 is approximately equal to m times x1 plus our y-intercept b. And look at this. We have a nice graph. You can see we have an R value. This time it's negative, and that's an important distinction for us. We'll talk about what that means, negative 0.916. You can also see what it looks like, how it's moving downward. So let's go and take a look and try to answer the questions. We've done the scatter plot, part A, we've done. Now part B says find the correlation coefficient. That's simply this R value. It's another name for R value. So negative 0.916. I'm going to go ahead and write that one in there. Negative 0.916. Missed the negative sign. There it is. All right, and the scatter plot is on Desmos. I'm not going to actually copy it over here. That would take a lot of time. Be kind of silly. Now here's the real value in these graphs. It comes down to predictions. So part C says to predict the gas mileage given a 210 horsepower engine. Now if you look back at the chart again, we knew horsepower was the input or the X value. So essentially what it's saying is we know the horsepower is 210. So what I'm going to do is go down here and type in an X value. X equals 210. 10. And here's what I really love about Desmos. If you want to know what the expected gas mileage would be, you just simply click on the point. So for a horsepower of 210, we'd expect a gas mileage of about 16.03 miles per gallon. Now sometimes the predictions go the opposite direction. And again, these predictions are the real value in regression. Predict the horsepower for an engine that gets 26 miles to the gallon fuel efficiency. So this time it's working the opposite direction. We know that the output, the Y value, is 26. So I'm going to go in here and type in Y equals 26. Now if it's too much, you don't really need this X equals 210 anymore. You can get rid of it just by hitting the little X right there. Y equals 26 is right here. I can see that point is 143.49. So I know it's 143.49 horsepower. We're going to do some more work with predictions as we move ahead. This is the real beauty of linear regression. It's a great topic, lots of business and actually life applications. I know this was pretty brief, but I hope this helps you to get started. You guys have a spectacular day.